Hey guys, how about a little unboxing video? I don't buy too much these days. I know I just was donated a bunch of TVs, but what I mean is in terms of stuff that I'm actually actively seeking out and have saved searches set up on eBay and I'm scouring the globe for. But this is one of the few items I have been looking for one of these for years. All because of one of my early influences on YouTube, which is the old 64 goat. He had one of these and he used it in a number of his videos. That kind of got me inspired to get more seriously into vintage electronics and start making my own videos. What this is a capacitor tester. And yes, I've got my trusty solar capacitor tester you've seen me use many times. Solar CB160, I believe this is. Which is fine. I mean, it definitely identifies leaky caps, but there's a few shortcomings to it. One, there's no meter. That's actually the main one. It doesn't show you the exact voltage across the cap. It just has this range of 0 through 5. It also doesn't show the leakage current. You can just infer it by how fast the light flashes on this. And then it uses a bridge and an eye tube to measure the capacitance against a known reference. It's a bridge circuit. This is similar in some regards. This also uses a bridge circuit to test the value, but this has a meter, so you can actually see the leakage current. You can actually see the voltage across the capacitor. What this is a pyramid CRA-1, and they are not easy to come by. It's probably taken me a decade to find one. Good condition, reasonable price, and I wasn't crazy about shipping it, but this was in my same state, I do believe. It actually arrived in like a day and a half. I wasn't expecting this for a few more days, but it showed up today. But I was on the fence. I saw there were a lot of watchers. I'll just come out and say it. It was 75 bucks. Which for one in this condition, I mean, the photos did not lie. I mean, for something that was made, I think, in the mid-50s. Early mid-50s, as near as I can tell. I mean, man, this thing, it looks like it was never used, or just barely used, so the condition is phenomenal. But they said they had done minimal testing, and when they put it on one of the ranges, I think the 60-volt range, the meter pegs hard over to the right. I imagine that's what scared off the other watchers. I was the only bidder. The reason I did it, I did a little research. And I saw somebody on the antique radio forum a few years ago, somebody in the Netherlands of all places, who had one of these. Had exactly the same problem. And I figured, well, somebody else has the same problem. But he said otherwise it seemed to work fine. That it can't be a critical issue like the power transformer being shot or something. I'm thinking there's two possibilities. One, it's user error, because there's a bunch of different mode switches and whatnot, and maybe they weren't putting the meter in the right range when they for that 60-volt range or something like that. Or it's a common fault. This thing isn't all that complicated inside, so I'm hoping we can fix it. It's missing one of the set of probes, so it says two distinct modes on it. It's got the quick check over here, which uses an eye tube. That's kind of like a pass-fail, just a real quick way to see if a capacitor is shorted or open or super leaky. And then the more exact mode, you can see the exact leakage current and show for a given voltage applied across the capacitor, and you get the value off of this dial. So this is the quick test lead. The leads for doing the more exhaustive testing are heavier gauge. I don't know that I trust the insulation. This thing goes up to 600 volts. I don't know that I'd want 600 volts across these leads. This insulation's quite up to it, so I'll end up just having a set of leads. That's no big deal. Alright, enough yammering. Let's get this puppy out. It's not as heavy as I thought it might be. They did a decent job packing. It seems to have survived just fine. Like I said, it didn't have to go too far, just probably a few hundred miles. Boxes of stand here and get a better look at it. So the only thing I know about using this and its operation, what I can do, is watching from the old 64 goat, because he was doing a demonstration of how to form up and test capacitors using this device. So one of the great things about vintage testers like this, and another great one, by the way, is the Sprague, or is it Sprague, Telemic series. I think the TO6 or something like that is kind of known as being the best. This one is pretty darn solid too. That has similar features. I think that also has an eye tube and a meter on it and so on. There's also a newer version of this, the CRA-2, but I think I like the one better. I like the way it looks and kind of some of the functionality. So it does go up 0 to 600 volts with this control down here. And it's got two ranges, a 0 to 60 volt range and then a 0 to 600 volt range. Two current ranges, a 50 milliamp, 5 milliamp. I should say those are the meter ranges. It's not the device range. This is the only voltage range control, but I guess is an aid, so when you're testing low voltage caps, instead of having to look on the 600 volt scale and just look at one little narrow section of it, you can drop it down just so it's 60 volts full deflection. Same on the current. So what? So why would you want to see the current and all that? Well, if you're going to try to reform an electrolytic capacitor, you want to monitor the current that's flowing through the cap as you slowly increase the voltage. And say your capacitor is rated for 300, maximum of 300 working volts. You'd want to start out at like 0 and maybe put in a 50 milliamp range and increase this. Let's say actually probably more like the 5 milliamp range. And ideally, when you're at 50 volts, 75 volts, 100 volts, your current is going to be quite low. And as you increase the voltage, if the cap needs to be formed up, as you increase the voltage, the current that's going through it is going to increase. I mean, ideally there'd be 0 current going through it. But when a capacitor is sat for a long time, or it's no good, you're going to have current. But by slowly applying voltage, you can reform the chemicals inside and build up an insulating layer. And ideally, you'd make it all the way up to 300 volts, or whatever the working voltage is on that cap. And the current would be down at an acceptable level, which would be, say, less than 1 milliamp. So that's the cool thing about this. Now, if you've watched my videos, you know that quite often I just shotgun the caps. More recently I haven't, because when I do shotgun the caps, because they're generally all bad in the stuff that's as old as the stuff I typically work on, but when you just shotgun them, and by shotgun I mean you just replace them all without testing them, you don't learn anything, you don't gain any troubleshooting skills, and you might be replacing parts that are still good. Or when you replace parts, it's nice to test the part you take out to see, oh yeah, it's really bad, and when I replace it, the functionality should be restored or be improved on the circuit that that part was in. So instead of just guessing that the cap is bad and replacing it should make things better, if you take out the old cap and just test it and it tests good, well, then the problem's going to lie elsewhere. This can also measure resistance, not particularly useful, an ohm meter's better for that, but it can check for resistance. It can be like a megger. That's a term for measuring very high resistance, so there's a mega ohm times 100 range. Basically, you can check insulation. Just like a capacitor, ideal capacitor has 0 current going through it, an ideal insulator has 0 current going through it. Well, this can apply hundreds of volts across an insulator. Like say you got a wire, an old wire, and you want to make sure the insulation is still good. Or better yet, if you're working on a set that's got no power transformer, and you want to make sure that the chassis is insulated from the power cord, that's one way you can do it. So. The seller has already said that there seems to be an issue with it, so I'm inclined to, rather than just plug this in and try using it, to pop it open and take a look inside. This does have several tubes. I think it has a 6L6. Well, actually, I included a copy of the service info, so I don't have to guess. It's all in here. I'm not quite up to speed on how to use this. Even if I plugged it in, I don't know that I'd be using it right. And here's what we should see inside. So there's a big old 6L6, which actually uses a rectifier of all things. So it's kind of curious. We got 3 tubes, a 6SN7 dual triode. We got the I tube, a 6E5, and we've got a 6L6GA, which they actually use as a rectifier. And I imagine, depending on the mode, this grid does something to the rectification. Limits the current or some such. I'd have to check the meter. I mean, that could be a very useful thing. If you want to check leakage current in a cap and that cap is dead shorted, you don't want to damage your instrument. So by having a tube in there that is self-limiting with how much current can go through this, you can avoid burning out the meter or power transformer. That might be why they use it. And this is how I knew what the other probes will look like, because I got a nice photo here. So I do not have these probes here, but I do have that one. So again, this is in remarkable condition, and I'm happy to get it, and I hope there's nothing critical wrong. So I want to pop this open and make sure that the tubes are present, and that they're seated, and that they're good, and that there's no obvious problem with capacitors that have spilled their guts, or wires that are broken loose, or anything like that. Then we'll see about powering it up. To open this up, well, let's see. A lot of equipment, the front actually comes off. And this might be no exception, because there are screws around the front of the cabinet. I think we have a couple trimmers in the bottom. I imagine those are for calibrating. And it can also be take those 2 off. I'm more inclined to the front pulls away. Well, I don't know, maybe in the service info they show how to get this apart. You do have to remove the 2 hex sheet metal screws. You do have to remove the 2 hex-headed sheet metal screws from the back, and then the 6 screws around the perimeter, and indeed the front does lift out. And I am immediately assaulted by that vintage electronics smell. Let's see what we got. Oh, this has been worked on, it looks like. It's kind of annoying. The power cord comes through the bottom of the case. So you can't pull it through. You gotta kind of keep the bottom of the case nearby. Stays attached to the power cord. Alright. Anyways, there we go. So, at least I think it's been worked on. I say that because I see some orange drop caps that look like they might be replacements. This power resistor looks a little funky, but you know, this is original. This power resistor looks very similar to one over here. This coil looks rather fragile. It's part of the bridge circuit. There's a power transformer. So there's a trimmer resistor down in there. Power resistors. Those two caps in parallel are rather specialized. They're selected to be 1% accurate. Don't want to mess with those either. I do see a couple paper caps though that could very well not be good, which is this guy and this guy. Yeah, ironically the capacitor tester may have bad paper caps that need to be recapped. Looks like the power cord's been replaced too, so that looks like somebody spliced in some electrical tape. But weird that the primary and a power transformer would just go right into the power cord and not tie into a terminal strip. Seems a little crude. And that could possibly be original too. Oh, no, there's two electrolytics here. So somebody asked me, is the company that made this the same as the Pyramid Capacitor company? Well, there are actually a couple Pyramid caps in here. And they do have the same symbol. The same Pyramid logo that you see on the front. So, yes, it is the same company. Just like Sprague had a capacitor tester too. And so did Solar. I mean, the Solar capacitor tester I have, so Solar made capacitors as well. However, when I looked this up in the Radio Museum, Pyramid didn't make this. It was made by some test equipment manufacturer out of New York. I'm sure it was contracted and they just put their name on it. I mean, a capacitor company, you know, that's not their thing. They don't make test equipment, so it makes sense that they would just contract out with somebody else to make one for them. So, what are we going to do? We're going to test these two tubes. And otherwise, it looks pretty sound, as I said, for those two paper caps. So I'll leave the back off, assuming these tubes test good, and then I'll put it through its paces, make sure it's working right. I really hope this 6L6GA is good. It's more commonly used in audio amplifiers, and not the cheapest tube around, especially for a nice old Coke bottle type one. I don't know if this is the original. Everything is pristine inside. There's not even a speck of dust in here. Also an RCA tube, which again makes me think that since these are matched, from the era, same logo and everything, these could very well be the two original tubes that were put in this device. Both tubes test like new, which lends a little bit more to my theory that this has seen very little use. So I tried powering it up and doing some basic functionality tests, and got a problem right away, which is exactly what the seller had noted, which is the meter pegs on the 60 volt range, and that's for a very good reason. It's because you can't get the voltage down below 100 and something volts. So this bottom scale here, the bottom scale, the reddish orangish numbers, that's volts DC. The black is current and the green is resistance. So there's a variable knob down here which should go from 0 to 600 volts. Right now it's at 0 on the 600 volt range, so we've got about 120 volts or so. I'll turn it up. I'm now at 300 volts on the knob, and we've got about 450 volts out. This meter is dead on. I compared it to a digital voltmeter, and the two are very much in agreement. So I trust this meter, which means there's something wrong with the variable voltage control. And that is exactly what several other people have had on the Antique Radio forum. And I just finished reading through one thread where somebody not only had this problem but tried to fix it, and he got a bunch of advice. Unfortunately, the discussion thread trailed off with no resolution, but certainly I've got some things that I can check. One is the voltage control itself, which is a combination power switch and potentiometer. I did spot check a few of the resistors. Almost all of them are wire wound, which are basically either they're good or they're open. They don't drift in value, and they do seem to be okay. And then people pose a few other things. So either the resistors, well, let me take a step back. So this variable voltage supply uses the 6L6 tube in what they called a grid-controlled rectifier. I think that's the equivalent of the solid-state series pass transistor you may have seen in variable DC power supplies. So that would be this guy right here, and there's that variable control. So they're controlling the grid. We got our AC coming through the plate, and it's taken off of the cathode. So basically you're varying the grid bias, which controls the amount of current that's going to flow through the tube. Schematic's a little annoying because for some of these components they don't show any value. And several guys mentioned that their resistors in here had two in parallel, and that's because they calibrated these at the factory by hand selecting component values to use. However, they do give parts values in the parts list for these, which I think are like the nominal values, and then they would tweak that in the production line, I think. At any rate, these two unlabeled caps here are two electrolytics. And since these resistors seem to be okay, that was the next culprit. Because if those are off, so that basically these do filter out the ripple of this tube, which is acting as a rectifier. So you can get pulsed AC on this cathode. Otherwise, I could try swapping out the 6L6. Because for just the basic variable voltage, we can ignore pretty much all that, and it just comes down to that. Got a power transformer, secondary. We got a tube with its plate going to one side of the secondary. The other side of the secondary is going to ground, essentially. And we've got some resistors loading down the cathode, it looks like. And we've got a variable control here. This 1 meg is also something I definitely want to check. I read the instructions more closely and I realized something, that when you're in the 60 volt range you're also supposed to flip this switch from high to low DC, which is a little annoying because it's spring loaded. I'm guessing that's to prevent damage to the meter, so that when you so imagine if you had this thing cranked up and you flip from 60 to 600 and you didn't change the switch, you're going to really risk serious damage to that meter. But anyways, when we flip this to low, put this on 60, now we can adjust it. It goes from, well, it doesn't quite make it up to 60, but it goes from about 5 to 60 volts. So this would be for testing lower voltage electrolytics. And it got me thinking that maybe this is right. Maybe this knob is not precisely calibrated in voltage. Although I'd feel better if it went from like 0 to 100, or where it didn't have any numbers at all. So I don't know how closely this is supposed to track. I mean, they give you a meter after all. Because otherwise this thing seems to pretty much work. Other than that, I mean, I did replace the capacitors. It's easy enough to do. So now we can test the capacitors with the capacitor tester. So let's go ahead and do that. I was also reading about those quick test probes. Oh yeah, so I should mention there are two two ways to test a cap. One is a quick test, and then a more exhaustive testing when you check leakage current and such. For the quick test, it uses an oscillator. And this is meant to go to fairly low capacitance. Well, meter leads have capacitance. You know, we've got two parallel conductors here with an insulator between them, so this is going to have, I don't know, some tens of picofarad of capacitance, I would imagine. This is designed to be compensated for that, so when you just connect these meter leads with nothing attached, it'll read as being open, but you could put like a 5 picofarad cap on this, and then it would show it as there being a capacitor connected. So, glad I have this set of cables. Otherwise, I'll use this set, which is what I use with my old solar tester. So you want to use this for this guy. So let's just dive right into checking for leakage. Turn this down, turn this up. So, idea is, you know, variable DC power supply, and we've got a combination voltmeter and ammeter. We can connect this to a capacitor, and we can measure how much voltage is across it, and we can measure how much current is going through it. And an ideal capacitor has zero current going through it. A really bad capacitor is going to have excessive current going through it. According to the manual, at least back in the day, a dry electrolytic type cap should have less than 10 milliamps of current going through it. So let's hook up one section here. Ooh. That was the 5 milliamp scale with the voltage all the way down. That's not a good sign. That's why they say in the manual, put this on the 50 milliamp range with the voltage turned down before you hook up your capacitor. Alright, that's better. Now these should be good for 450 volts. So let's start turning this up. Well, that's good. So I turn this up and the needle's dropping, which is what a capacitor will do that's been sitting around for ages. That's still good. It's the dielectric is forming up. It's a chemical process that builds up an oxide layer, I do believe. It's still a lot of current, though. It's supposed to be less than 10 milliamps, so let's see, 600 volt scale. So we've got, keep forgetting this knob is, so this probably is an issue now I think about it, because we're only up halfway on this knob, but we're almost full scale on the voltmeter, so that's not so great. I didn't realize I was already up to 450 volts, so let's back this down to 300 volts. And now let's check the currents. So yeah, that's good. These caps, probably didn't need to replace them at all. Oh well. We'll check the capacitance after this in a bit. So let's just go up to 450 and check the current again. It's a little high. We're 2 milliamps. High by my reckoning, by modern cap standards. A modern 8 microfarad 450 volt cap would basically be 0, or it'd be microamps. I would not expect. According to them, less than 10 milliamps is okay for a brand new capacitor. Here, I'll pull out a going up another 10 microfarad 450 volt cap. Oh well, there's a 22 microfarad 450 volt cap. Now you got to be careful when you do this because these leads are hot. I believe that's what the discharge switch is for. You can certainly turn this down. You may have noticed when I turned the voltage down, the meter pegged the other way. That's because I shouldn't have done that. I left this in current mode, and when you turn the voltage down, the capacitor is now putting that stored energy back into the device. That's why they have a discharge mode, so you can safely discharge the cap without damaging the meter. I'll get the hang of using this thing eventually. Alright, so a modern cap. Let's get this guy. Let's put this at 300 volts. Now check the current. Higher than I would have thought. It's a cool thing about having this versus the older solar tester I had, which just has an eye tube. and you get a neon light you can watch to see if a cap is discharging or charging. I had no idea how much current might be going through a modern cap, and that is higher than I thought it would be. It's not really dropping either, which I find a little surprising. Or it's dropping very, very slowly. And I've read that if you look at a modern data sheet for a capacitor, you might think, well, brand new cap, right out of the package, it should be ready to go. No. The longer these sit, the more you have to reform them, especially if they've been sitting for a year or two like this probably has. Yeah, you need to form it up before it reaches the data sheet specifications. And this can take quite a while, minutes, hours even. The cap's been sitting around for a very long time. Let's get this up to 450-ish. I don't have the data sheet handy for this. It's a decent quality name brand cap. But that seems a little high. So I'm going to find one from a different brand. Well, here's a Nietzsche count. It's a 47 microfarad, twice the capacitance, but same voltage rating. So let's see if I do this correct this time. Let's turn that down, turn that down. And, oh, my bad. I was in discharge mode the whole time. Jeez. Where is my brain at? So I was actually measuring the discharge current through this device, I believe. Oh, man. It's a Monday. I haven't had my coffee yet. That's what I was expecting to see. 5 milliamp range, 450 volts on this cap, and that needle is pretty quickly going towards zero. Alright, now let's try. I'm kind of curious, I'm in discharge mode now. So what kind of voltage do we actually have on those leads? So one of these days I'm going to end up shocking myself if I'm not careful with this thing. That's good, there's no voltage across it. So even though this meter says right now over 100 volts, there is not 100 volts on that. And just to show you how accurate this thing is, let's get this back on. I'll set this for 300-ish. Put the voltmeter on there. 295, 296. So 297. That meter is pretty darn accurate. Charging as I pulled it out. Let's try the 47. And we go back to leakage mode. And let's go up to 300 volts. Current. It's already well below 1 milliamp. 450. That's what you want to see in an electrolytic capacitor. Let's turn this down. Yeah, screwed up again. Don't turn the voltage down while you're in current mode. Let's charge that guy. And let's go back to the old cap. Do the other section this time. Leakage. 300 volts. Current. This section seems to be doing a lot better. Let's go 450. So yeah, this cap seems to be pretty healthy. Check the other one again. 150. And yeah, I probably did not need to change out either one of these caps. I don't mind, because I probably will be using this fairly often. And I put in some high quality brand new name brand caps, so I have to think about it now. So let us do now the capacitance check. I'm not sure if it's safe to change modes with this hooked up, so I'll just do that. C times 100. Kill the light because we're going to be using the eye tube for this. It's kind of funny, since the only rectifier in this is the 6L6. To power the eye tube, you have to actually set this at 450 or so to get juice going to power the, make the eye tube glow. Oop, wasn't expecting that. Must not have discharged that cap. Now you look for an eye open, just like on the solar tester. The bridge is balanced right about there, which is about 9 microfarads in a little bit, like 9.3 or so. Cool. And let's check this guy. Or sparkage. About the same. And let's check this modern 22 microfarad cap. That is 22.5 microfarad. Cool. So other than the seemingly excessively high voltage on the 600 volt range, it seems to be working. On this guy, we balanced it around 40. I mean, we're like really at the edge of what this thing can do. And there is a high C mode. I'm not entirely sure what that does. We kind of got an eye opening here. So I thought this thing could measure more than 100 microfarads. Oh yeah, high capacity microfarad. That's what the red ring is for. So 47, yeah, it's right around between 0 and 100. I got a 2200 microfarad cap handy. Heck of it. Let's give that a try. Although it's only a 16 volt cap, hopefully this will be blowing it out. Does this go with that high? Okay. Maxes out at 2000. Well, there's a 150 microfarad cap. Let's give that a try. Yeah, right about 150, 160. Cool. Eye tube's not great though. The glow's bright enough, but the pi wedge is not super distinct. Often there's a resistor built into the socket on eye tubes, but on this I can see it's external. There's a 10 meg resistor. Let's check that out and see if that is excessively high. Now it's a really, really common thing to check in radios, where they often bury this resistor inside of the eye tube sockets. You gotta dig it out and replace it because they're almost always bad. Hmm, 2.5 meg. That seems a little odd. There is a cap connected to it though, so I might have to isolate that. Oh, I see. Oh, well, maybe that's the resistor. There was another one that's... I see. This is... Actually, I think this is the resistor I'm thinking of. a 1 meg. Yeah, it's 1 meg. Alright, maybe it's just a weak eye tube. I do like, though, that another thing I like about this is you can do a lot of the functionality without the eye tube, which will prolong its life. The problem with eye tubes are getting scarcer and more expensive all the time, and to have test equipment that has the eye tube powered up all the time is going to shorten its life. But you can do a lot with this. I mean, all that electrolytic forming up and testing, leakage current and all that, you don't need to use the eye tube at all. And although they don't talk about it in the manual, you can check leakage current through a paper cap. You just treat it as if it was an electrolytic. I was playing around with that earlier. So, nice. I will continue going through it, and I don't exactly have a whole lot of 6L6s lying around. I'll try to dig one up, because that's a simple enough thing to do, is just swap out the tube. It actually kind of pegs the meter on my tester. And I know that experience and from plenty of guys online that the best way to test a tube is in an actual circuit, and power tubes can be a little tricky to test in a tester because you're not putting anywhere near full operation load on it, either with load or the plate voltage. So that will be a quick test. I'm trying to think where the heck would I even have one. Well, I'll have to hunt around. Well, looks like it's my lucky day. I was about to give up on locating a 6L6 when I came across that box of tubes I got, along with a bunch of TVs I was given recently, and what happened to be in there? A new old stock RCA 6L6G, exactly what's currently in this, and it does indeed appear to be new old stock. So let's pop this in, see if it makes any difference whatsoever. I looked around more online and came up empty with other people. I mean, I found several other people who had the same problem, but nobody who ever resolved the problem, or at least never posted that they had resolved it. So let's see if this tube makes any difference. See, 300, no, 300, we're at 450. Exactly the same problem. Well, there's not much left to check. The resistors measure okay. I mean, there's not much to it. Here's a simplified version of it. So we've got the transformer, low-high switch, variable resistor, controls the voltage. There's a filter network and some bleeder resistors. Well, I thought these were equalizing resistors at first, but if they were, they'd be attached to this point, and they're not. So I guess those are bleeders. Well, I'll go over things again. And so I measured across the ends of this pot, and it does measure 500K more or less. But I did not check the action of the wiper. Maybe it's not making it all the way to one extreme. So, yeah, I'll do some more poking around. I also read up a bit more about this quick test. I didn't realize this was an in-circuit tester. I have another one kicking around somewhere. I can't remember what brand it was. I never really used it much. It's kind of a gimmicky thing about the claim that you can test capacitors in circuit. So, normally you clip out one end of the capacitor to isolate it from the rest of the device, and you test it. But potentially some tests can be done. So what they typically do is they use RF. This oscillator runs at around 8 megahertz. That's what that 6SN7 is for in there. And there's the circuit for it. Well, I don't remember the exact theory of operation, but supposedly you can locate short circuits, open circuits, and intermittents, high F RF impedance, and power factor in capacitors by using this with the I tube. Doesn't always work depending on the circuit, and it doesn't work with every type of cap. Honestly, I don't see myself ever really using that, so I'm not going to dwell on it too much. I'm far more interested in actually isolating the capacitor and measuring it and making sure at full rated voltage it has minimal leakage current. I also need to correct myself a little bit about what is acceptable leakage current. There's some charts in here and some formulas, but basically when I was saying less than 10 milliamps, no, they do say, I believe, it's less than 1 milliamp. They say you should keep it below 10 milliamps while you're forming it up. But it should be 2 milliamps or less after the rated voltage has been applied for 30 minutes or more, is what they give as a general rule of thumb. There's a lot in here about what's the acceptable tolerance for different types of caps and what's the acceptable leakage, and so here is, they got a little formula here for leakage current in milliamps, rated capacitance, and then depending on what the rated voltage is, and you can kind of guesstimate what the acceptable leakage current is for the RETMA standards. They do say it should never exceed 10 milliamps. But anyways, this manual, I believe, is freely available for download online. I'll try to remember to include a link to it if you want to read more about that. But basically, the lower the leakage, the better, ideally. Perfect capacitor, zero leakage. So I'll have to do a little more troubleshooting with this. But it does seem to work correctly. Well, I went over a good portion of the circuitry. Certainly all the stuff related to the variable DC supply and leakage testing. And I did not find any problems. And it strikes me as very odd that I found 3 other people online that described exactly the same problem, and none of them were able to figure it out. So rather than banging my head against the wall, I've got other stuff I need to move on to. It seems to work. Other than the variable DC supply being way off scale, it seems to work just fine. So if any of you guys out there have any thoughts on what I can check, please let me know. Here's the circuit. There's not a whole lot to it. I know there's component values missing, which doesn't help, but they do have very detailed service info in regards to showing a detailed artist rendering with a parts locator, and they do identify the parts component in the parts list. What I think I may end up doing is just tinkering with these component values to get it to work the way I want. I mean, it seems to me I could try increasing that resistor or increasing the load here to try to pull that voltage down. I don't know, but as I say, other things to move on to, and I will definitely try using this on the next project. I'd like to leave you off with a little update. One, it's been really hot and humid the past couple weeks. Things are just starting to cool off. Part of the reason for that, though, is because we had a massive storm blow through, which included some tornadoes. And we think one of them touched down very close to us, although we did not get a confirmation on that. Certainly one did about 5 miles east of us. And closer to home, just 1 block south and southeast of us, a lot of damage. We are very grateful and we're extremely lucky. We have 2 massive maple trees that we think are as old as the house, which means they're over 100 years old. And a lot of our neighbors' homes are about the same age, and they have equally massive trees. Unfortunately, a lot of them either toppled over or were severely damaged. Cars and trucks were smashed, damage to homes, windows blown out. Days later, there's still power out. A lot of mess to clean up. So we got that going on, unfortunately. I gotta get back to some other projects. So there's been an event in the Admiral 20B1 project. The owner of the set took a trek out to Ohio and went to the Early Television Foundation Museum in Hilliard, Ohio, and secured a replacement 12 LP4 picture tube. It is used, but they tested it there and said it tested really good. I have not checked it yet. I can see that it does need to have the DAG outer conductive coating replaced, so we got to do that. I know the owner's anxious to see if the picture improves. And this is a crazy hobby. Sometimes you got to go to those lengths to get the replacement parts, unfortunately. And I got to get that radio done. I really want to get the set back in his hands. I know he's anxious. He's been watching the progress in all the videos. And I got to get back to the GE800. That set is long overdue to get finished. And I want to wrap up those two Admiral 1911 projects that were a lot of fun to work on. And I hope to try out this Pyramid C CRA-1 when we work on the radio for the Admiral. And I know I've gotten a lot of requests for radio projects, and I hope to be doing some really soon. But that is it for now. Take care, everyone. Not sure when the next video will be, but hopefully not too long. I got to get back to some other projects. So there's been what am I trying to say? There's been